Okay, I think we're live. Wes, well, thank you for coming.
Yeah, thanks for having me.
Yeah, thank you for exposing yourself to questions. I just as a little bit of an introduction, you spend a lot of time doing bug bounties, and you do a lot of web hacking, if I understand correctly. And I was hoping that you can kind of walk us through that a little bit. Like, what's it like to exist in that field?
Yeah, for sure. So I actually didn't get my start in web hacking, kind of transitioned over to doing a lot of that in recent years. It's kind of funny because, I mean, the web's been around a super long time, but I used to think, oh, web hacking's kind of lame. The real hackers, they do real exploits, they hack servers. No one cares about web applications. But I was kind of wrong on that. Everything's a web application now, and it's actually the main things that matter. So yeah, the last 2-3 years I've been doing bug bounties full time, and bug bounties most often focus on web applications. So I've actually looked at hundreds of web applications over the last few years and found vulnerabilities in most of them.
That's very cool. When did you make that switch?
2018, I was working at Microsoft and wanted to move back to Canada where I'm from. So I decided it would be a good chance to try out bug bounties full time and see how that went.
Very cool. And how is it working out for you? You're paying bills and all that?
Yeah, so far so good. Some days eating instant noodles. No, it's been really good. I keep having people saying, "Hey, you should come for this job or whatever," and I tell them, "Oh, I can't. Bug bounties are going too well."
I mean, that gives you a level of freedom that very few have. So it's pretty awesome that you can do that.
Yeah, no, all around, I've really enjoyed it.
So you did that switch. You went from kind of like binary analysis and binary hacking. You went to web hacking. Would you say, like, which one's harder? Like, which one do you enjoy more?
I think web hacking is a lot easier to kind of get started in and do some basics. Like I said, at first I thought it was kind of not very difficult or exciting, but having done it for quite a few years now, there can actually be some pretty involved vulnerabilities to discover. So it can actually be super interesting. Um, I think it really just depends how you like to approach vulnerability finding. Sometimes with exploit development, you might spend a really long time trying a bunch of different paths to finally get something that works. Like you could spend a month getting a good exploit working potentially, just because of so many pieces that all need to come together. Whereas most web application vulnerabilities you can fully explore within a day, sometimes just a few minutes, and you've got your vulnerability working. So there's just a little bit of difference there. The flip side is if you're looking at a big web application that's been pretty well secured, I've definitely spent weeks trying to find a path in before I finally get something working.
Mm-hmm. What does your tool set look like when you're hacking web apps?
So for web apps, I keep it pretty simple. One tool that I think is super useful is something to brute force application paths. So your web application will have hyperlinks and things you can click on that take you to various pages. But probably 50% of the issues I find involve pages that aren't linked normally on the website. So there's a tool to directory brute force or page brute force that I use with a word list. So I have a few word lists. One's about 1,000 lines long, one's about 30,000 lines long of just common paths and names and file names and that kind of thing.
Mm-hmm.
And then I have a tool that just runs, say, 50 threads and tries as many paths as it can and records. Does the server say, yes, there's a page here, or does it give a 404 and say, no, there's nothing there? And so that often uncovers debug pages or old pages that were in use but have been forgotten about, admin panels, all kinds of things. So I have a tool that does that, and I use that pretty commonly. And then for the remainder of my work, I use Burp Suite, which covers quite a few different functions. But it's an intercepting proxy, so I can see what my browser's sending and what's getting sent back. And that can be really useful for when you've got a modern web application and a lot of stuff's being done through JavaScript. So seeing the actual API calls that get sent by the JavaScript just saves a lot of time, and you can directly edit those instead of needing to do it through your browser. I usually use all three web browsers when I'm testing. So I'll use Internet Explorer, I'll use Chrome, and I'll use Firefox. Safari is not really a web browser, so I don't pretend it. I pretend it doesn't exist.
That hurts my heart.
And then if need be, then I'll use some more specialized tools. Like if I'm working on a SQL injection attack and I need to automate some stuff, I'll use something like SQL Map. But for the most part, it's really just my web browser, Burp Suite, and a directory brute force tool. I usually use WFuzz, but GoBuster is also really good. So one of those two, and that's pretty much it.
So the directory traversal tool is WFuzz, or you have a custom one?
Yeah, I use WFuzz, and there's another one called GoBuster.
What about the word list? Do you create that yourself, or do you use it from somewhere else?
A bit of both. So I found a few good word lists. They're online if you search for directory word list. And then what I did was I took one of the bigger ones, narrowed it down a bit, and then took a few small ones and kind of added them to it. Because some word lists have a lot of paths that come up, but not very commonly. And then some are just too small to find anything good. The other trick I have with that is I have one that includes a page name extension, so like .html or .jsp or that kind of thing, and then one with all of those extensions removed. So sometimes what I'll do is I'll see a website and it's running ASP, so I can take what would have normally been JSP page names and just append .asp manually, and that saves me needing 20 word lists. I can just use one and tack on whatever extension I need.
Very awesome. Sounds like you're automating quite a lot of stuff. So let me see if I understand this correctly. You have this WFuzz tool that's running on multiple threads. Is that like a configurable thing, or did you have to set that up yourself?
Yeah, WFuzz was kind of one of the original path brute forcing tools. The idea is if you just request page by page one at a time and you've got 30,000 pages you want to try, that's going to take a really long time, maybe 8 hours or something. But since it's a web server, it's designed to, be web scale. It should be able to handle a lot of requests at once. So you can give it 20, 30, 50, 200 requests at once. And then that makes it go a lot faster. So WFuzz supports using however many threads you want to. I think by default it's 30 or 50 or something like that. And that speeds up the requests quite a bit.
And this is just for you to discover the pages that might be vulnerable. Like you would WFuzz them based on your custom list, and then whatever the positive results come back, then you use something else to actually analyze those pages.
Yeah, so it's a bit of automated, a bit of manual, because often if I'm testing a new web app, I would take the base path of that web app, take the word list, run it against it. And usually 3/4 of the results are pages that I already see linked to on the website. So I don't really need to be too interested in those. But the ones that I didn't see on the website, so say there's 30 results, maybe 10 of them will be ones that aren't normally linked to. And then those ones are often good to explore because maybe they are linked somewhere, but it's a much more obscure page. Or maybe, like I said, it's a debug page, an admin page, something that you don't normally see.
Why do you think those pages exist? Why do developers put them there if they're not linked from anywhere?
Usually it just depends how mature the web application is. If it's some company's internally developed web app, often they don't have great development practices. So they've got their README files still in there. They've got all their test pages still in there. And they just published it as an app because the main pages worked and they didn't look at it any further. Whereas other websites, like say I was to run this against google.com, I don't think I would get any results that were unexpected. So it's also actually a quick way to get an idea of how well maintained a web application is.
So once you know how well maintained it is, what do you expect from the resources that you find? Like what kind of vulnerabilities do you end up finding that way?
So usually one of two things. Either I get directly to a page and it just gives back sensitive information. So a few of the items in my word list are commonly exposed debug pages. So ASP has a debug application that'll just show you all the session state that's been happening and all the requests that happened recently.
That seems useful.
Yeah, and it's great as a debugging tool, but if it's live on any real application website, then you can see everyone else's sessions. And so that right there is a big vulnerability, basically lets you take over anyone else's account. So sometimes that's all you need. Other times I'll find something more obscure within the application that either used to be supported or is still supported, but I didn't normally see when first looking at it. And often those pages are ones that have been less well tested. And so those ones I often like to spend most of my testing time on, because usually other testers haven't tested it, and usually the developer hasn't really tested it as well. And those are often where I end up finding vulnerabilities.
That's very cool. What kind of vulnerabilities do you end up finding? Like, I guess let me rephrase that. What sort of vulnerabilities do you tend to hunt for? I mean, like SQL injections, cross-site scripting. What other things?
Yeah, I'm like an equal opportunity vuln hunter for web apps. I look for pretty much everything. So cross-site scripting, cross-site request forgery, those are kind of like the bread and butter of web apps. Some of the latest browser changes make cross-site request forgery a lot more difficult to actually exploit. So that one's kind of going away. SQL injection is a great one to find, but is much less common. So cross-site scripting is always kind of my go-to one. And then my second most common is authorization issues. So pages that just aren't properly authorizing who can view it. So sometimes you just directly access someone else's ID and you can see their stuff. Sometimes there's a bit more to it. But those two are the first ones I look for. And then it just really depends on what the page is supposed to do, what I'll try. If it's something that exports to PDF, maybe I can do a path traversal on the file system and get it to write that PDF somewhere it's not supposed to. Maybe I can embed dynamic content into that PDF that it renders. Maybe I can access other people's previously generated PDFs. So depending on each function, I'll try and approach it in a way that I think makes sense.
Do you ever find more customized type of attacks? Or do they tend to fall into these categories and you just kind of go from there?
Yeah, I think something like the OWASP top 10 list of web app vulns is pretty accurate in terms of what I see. Definitely on occasion, I'll see something that's pretty custom, pretty unique, and not something I usually find. But usually it's actually just one of the well-known categories is where that issue falls.
Yeah, that's really funny. I never really see that list change very often. Like sometimes they'll change priorities depending on what they've seen last year, but it's all kind of the same bugs repeating over and over and over. I mean, is there any hope of actually getting them patched and getting rid of those bugs altogether?
Yeah, when I first started looking at more and more web apps and started realizing that, I spent a little bit of time thinking about it. Some of them, there's hope, but only with big changes. So CSRF, like I was just mentioning, is a good example. The only way to really fix it is to break a ton of existing web applications. But Google and the rest of the standards people decided that would be worth it just recently, I think just in the past year. So they went ahead and did that and kind of put everyone on notice, hey, you're going to start to see more and more issues with your web application until you update it because we have a new standard. Things like SQL injection has kind of been a solved problem for more than a decade now. It's just a matter of developers properly coding things, which is kind of an unsolvable problem. Most developers will properly code things, but many of them won't.
Is it just too tempting for them to take shortcuts and not sanitize their strings? Is that why, or is there
Yeah, I
something a
think
bit
so.
more?
I think it's a little bit of lack of knowledge in some cases. Some web apps are pretty easy to build, and then you just need to add in some database functionality, but you don't know what you're doing. So you look at a few examples on Stack Overflow, patch it in, and you're done. I think that definitely happens on occasion. And then I think, well, I've definitely seen applications where they do it right in almost every spot, but then in a couple they do it wrong. And I think in those, it's just shortcuts. The developer was testing something, it worked, he was going to come back to it and do it properly, but never did. And just kind of moved on. I think that definitely happens quite a bit as well. So things like SQL injection could go away, but requires good development practices. So will probably be with us for a long time. And then cross-site scripting is the one I don't think we're ever going to solve. It's just too difficult based on how web applications are supposed to work to avoid it taking place.
So what would you say? Is it easier to be on the defensive side on this one, the developer side, or to be on the offensive side? Like, are you bound to find vulnerabilities in pretty much everything you look at?
Well, yeah, I've definitely told people, I think making a large web application that is completely immune from cross-site scripting attacks is basically impossible, which is a kind of a strong statement, but I think it's like you can use frameworks and this and that, but there's just, you only got to get it wrong once and then you've got a problem. Yeah, I definitely think there's a lot more to keep track of when you're developing an app versus just security testing it. As a security tester, I've just got that OWASP top 10, just kind of grind through each category. The developer, you got to worry about making your web application do what it's supposed to do. And you got to worry about that list of 10 things that you might have done wrong. And it's actually, you know, a list of 100 things, but 10 of them being more common.
So do you think that using frameworks actually makes the situation better?
For web applications, frameworks is definitely the way you want to go. Cross-site request forgery used to be solved by using a good framework. Cross-site scripting attacks are often solved by making use of various frameworks. It's a bit of a two-edged sword because then what happens is security researchers really start to focus on the popular frameworks, because then if they can find a vulnerability in the framework itself, they can use that against a lot of websites. But overall, it still, I think, helps more than it hurts to use a framework. There's even things like web application servers. So IIS by Microsoft, it has a bunch of protections in place for cross-site scripting, trying to help websites prevent it even if they've coded it wrong. So there's lots of layers you can kind of add to a web application to try and get it more and more secure. Overall, it's kind of like everything in security. The more simple you can keep your application, the easier it is to ensure that it's secure as well. And complexity usually just leads to problems.
That's funny. I remember when I was just studying cybersecurity, it was called information assurance back then, and like 20 years ago. That was the thing that they were trying to teach all of us, you know, keep it simple, stupid principle, just to make sure you don't overcomplex and create lots of problems in your applications. So speaking of frameworks, I mean, I think Equifax had a bit of a problem with that not long ago. Is that what happened there? They relied on this framework and then they suffered an exploit. Do you know anything about that?
I cannot confirm or deny if I had anything to do with Equifax. No,
well, just more from the academic side. I'm not asking what you did there.
Right. So my friend says that it was one of their Java application servers that got hacked due to a deserialization issue, which affects a bunch of Java application servers. And so, yeah, I mean, that's kind of, it's a problem with any application, web application or not. So you could tell someone, well, if you're running Windows and the new Windows exploits come out, is it your own fault because you were running Windows? It sounds good until you look at the alternatives. What are you going to do? Run Linux, run Unix, run a Mac? Turns out they also have exploits come out for all of them. So at the end of the day, you need to run something. I think the goal should be to find a framework that has a pretty good track record of not only avoiding security problems, but being able to respond to them well. So the Java application servers, I mean, a few of them just consistently have issues. I don't know if it was WebLogic that was used with the Equifax hack. It was one of them anyways. In WebLogic, every year I see a bunch of new critical issues be reported for it. Yeah, and I'm not sure why that is. I think it might just be it's too complicated of a server and a poorly designed system all leading to these exploits. The other piece of it though is a lot of those application servers, the vulnerabilities are in the administration interfaces. So I'll find lots of WebLogic applications when I'm doing web testing, but the admin portion won't be accessible. So there is things that can be done to limit your exposure. if you can get to the internal network and get to the admin panel, then it doesn't really matter. But at least for your public facing websites, I think a lot of the vulnerabilities and frameworks end up being on the admin side of it and not the user facing side, at least not as much.
That's very interesting. So let's say you are looking at some web app and you find, I don't know, a SQL injection. Like, what do you do then? Well, aside from just reporting it and being a good citizen and pointing it out to the developer, you may want to find out like how impactful it is, like how much damage this thing can do to the customer. Like, what do you do at that point to develop an attack?
Yeah, so assuming the customer wanted me to develop an attack, because I always closely follow the rules.
This is exactly what they ask you to do.
Yeah, a SQL injection is a good example because on the one hand, it can be a pretty impactful attack. You can basically run commands against the database, but there's actually quite a bit of variation. So sometimes you'll have a database account and it can only read from the database. So you could maybe read everyone's data, but you can't actually alter it. And so then it depends, well, what data is it in the first place? I found a SQL injection vulnerability, and it was basically just a help system for some company. And all I could do was read data out. So I could see all their tables, see how they'd structured their data. But at the end of the day, the contents I could get were no different than I could just read off of their help website. If I'd been able to alter that data, then I could have had more impact because that data was directly being used in a web page. So I could have, as an example, inserted a cross-site scripting attack into their database content. And then when you viewed the help pages, that would have triggered. So usually when I first find a SQL injection vulnerability, my main thing to do is confirm that it really exists. And then the second thing I want to do is see what permissions I have. Can I edit content? Can I only read content? Can I actually access other databases? A lot of database servers will let you read from other databases, not just the one that's being used for your SQL injection attack. So sometimes that works.
And that's if the database was poorly configured, that allows users to kind of cross different paths. Is that what you're talking about?
Yeah, I don't know if poorly configured is the right word, but if a user account that they're using for the web application has access to multiple databases and they haven't really done fine-grained access control, then often it's possible to tell the database server, hey, I'm selecting from this database normally, but actually I want to select from a different one. So in my example of accessing the help system database, if that was using a user account that had access to all the databases hosted on that server, maybe I'd be able to read customer data instead. So I've seen that happen in the real world quite a bit.
And what sort of tooling do you use to develop that attack? I mean, you are experimenting. You don't know what sort of access the user might be having, but you have some kind of SQL injection attack. So what tools do you use to develop your exploits?
Yeah, so in that case, I'd be using two things usually. I would be using Burp Suite just to simply send the request to the server and record how it responds. You could use your web browser in many cases to send the SQL injection attack, but often the response gets recorded through an error message and doesn't show up well on the web page itself. So you want to see it on, so it's nice to see it in a tool like Burp Suite, which just shows the raw HTTP request and the raw HTTP response. Mm-hmm. Then normally I would try and configure the tool called SQL Map. And it's a tool made specifically for exploiting SQL injection vulnerabilities. What it's really good for is a lot of the time you'll have a SQL injection, but you don't actually get any response back. Your injection is taking place, but the server doesn't send you an answer. And so what you can do is you can tell the server to run a delay command. And I don't know why databases normally like delay commands, I guess because of ETL processing and systems are terrible. But you could tell it, wait
probably
5
some
seconds.
Kind of a legacy thing.
Yeah, wait 5 seconds for the big iron to finish processing and then spit out the database result. So you can use that to your advantage because you can say, as part of my injection, I want you to delay 5 seconds. And then Burp Suite will tell you how long a request took to come back. And so you could see really quickly, oh yeah, this took exactly 5 seconds. My delay is working. The tool SQL map will automate that, and it will say, okay, delay 1 second if this condition is true, and if it's false, no delay. And then it will record for you, yes, there was a delay, or no, there wasn't. So it can do what's called a blind SQL injection attack and still be able to extract information and details. It's also just good because it has a lot of the underlying commands already structured. So you don't have to figure out, well, what is the exact format I need for an Oracle database versus MySQL versus Postgres or something.
Well, that's convenient.
Yeah, it knows a bunch of database types, so it knows how to list out your permissions. It knows how to list out the tables. The flip side, though, is that half the time it just doesn't work. Since
how do you deal with that when it doesn't work?
Yeah, since you're trying to actually exploit an application, there's no consistent way that it has to work. So I'll often spend quite a while trying to get SQL to map to work because it's way more convenient, but sometimes it doesn't. So then I just exploit it manually. You can look at the timing differences by hand if you need to. You can look at the error messages by hand. Often what I find is it works partially, but not fully. So it is good to have a list of, well, what's the Oracle command you run to find out your account permissions? Or what's the MS SQL command you run to find out your account permissions? And then maybe that tells me I do have the permissions, but SQL Map's just not using them. And I can know to try and configure that further.
So how would you, if you have this blind SQL attack, how do you use that to extract information from a database? I mean, you can't get actual text back.
Yeah, so what SQL is a pretty functional language. So it has a lot of functionality you can use in addition to just, return me a table of data. You can tell it to do various calculations or data transformations. And so it can do comparisons for you in a number of ways. So say I've got a blind attack and I'm trying to read out the user's password table. I can tell it select admin user and return password, but actually only return the first letter of the password. So that's a pretty easy SQL statement to write. And then I can add in one more comparison and I can say, return the first letter of the password. And if the password starts with the letter A, perform a 2-second delay. And then I can hit go. And if the server responds pretty quickly, less than 2 seconds, I know the first letter wasn't A. So then I can say, okay, try it with password first letter B, and then just kind of iterate through that till I see the answer. SQL Map does.
You have to basically do all 26 characters or however many possibilities are for each of the characters.
Yeah, and so then it turns out one of my intro to computer science courses was useful, and doing a binary search is a more efficient way of doing it. So I can actually ask it, is the letter less than P? And if it's less than P, return, and if it's greater than P, don't. And then I can narrow it down further and say if it's less than H, return quickly, or if not, 2-second delay. So that's how SQL Map does it. You can do that by hand if you really want to. There's, depending on the database, other techniques though. So you can actually ask some databases to try and retrieve information from a remote server. And so what you can actually do is tell it the remote server's host name makes use of the result from this query. So I can say, look up on the remote server password.server.com. And so then server.com is a domain I control, and I can just wait for the DNS request to come in, and the DNS request will have the password right in the DNS request. So then I don't have to do it character by character. I can actually just do it by having a DNS server that the database tries to make a lookup to.
That's really clever. So you get the password from the database, you append it to a domain lookup, and when the domain lookup goes to your server, you already have this information. So you kind of have this triple thing in play, but you have to control the client and you have to control the DNS server in that case.
Yeah, what's nice about that is probably 80% of companies I've seen that block outgoing communications don't block outgoing DNS requests. So it gets around a lot of firewalls on a lot of systems. SQL Map actually supports it as a way to extract data, but it's never worked for me. Like so many SQL Map functions, it's there, it looks like it should work, but it doesn't. But you can do it by hand pretty easily too.
So SQL map is a good way to start, but not really a good way to keep going. You have to keep adjusting it, keep playing with it.
Yeah, I mean, when it works, it's super good. When you battle it a bit and then it works, it's still good. It's just like the impossible to guess problem. Am I going to spend 5 hours making SQL map work and I could have just done this by hand? Or will I have it solved in the next 10 minutes?
That's really cool. I mean, what you're talking about, this sound like pretty advanced skills. Like, how did you acquire that? How did you train yourself to know how to do these things?
Yeah, so for computer security in general, it was just something I kind of got interested in. Way back in the day, there actually wasn't a lot published on how you do it. You had to kind of dig around online, see what you could find. It was super funny because I remember I had never heard of an exploit, and someone finally said, well, just look up some exploits. And I was like, well, what's an exploit? These days, it's a lot easier. There's a lot of good training, a lot of good guides that you can go through. And that's usually what I tell people if they're trying to learn a new area, or what I do is I just look up, okay, well, what has someone else done? If they're trying to do a SQL injection attack, how did they do it? And then I try and kind of follow all their steps. I try and set up a vulnerable system, follow the steps, see if I can make it work as well.
Mm-hmm. So you practice the flow, you practice everything that they talk about in your own home setup.
Yeah, exactly. And so when I started off doing web application stuff, I had known quite a few of the basics. But then I spent a lot of time reading anytime someone would publish a blog post on kind of an interesting vulnerability they'd found, because often they'd be covering a technique that is documented but not as commonly used. And I found that was a really good way to kind of learn more about them. But almost in every case, when I would try it out in the real world, it wouldn't work quite as they'd described it. So the practicing part of it has really helped.
That's very cool. Do you play any capture the flag competitions?
On occasion I do. Since I do bug bounty stuff, I'm always kind of conflicted, because bug bounty I feel is almost like a real world capture the flag. But capture the flag events can also be great ways to learn and to practice. Some of my friends do CTFs all the time. They get to the DEF CON qualifiers and all of that, or get through them and get to the real event. So sometimes I join them. HackerOne's been doing quite a few web application CTFs. So a lot of CTFs are more on exploit development and less on web applications. So they just did one this Christmas that I did, which was a lot of fun. So sometimes I do them.
Okay. What do you think about them as a learning tool? I think in terms of how closely they represent the real world.
Yeah, I think they're super useful in terms of reading through people's solutions and trying them out. Because often what will happen is there's a CTF, it comes out and it's got some easy, it's got some medium, it's got some hard problems. Hopefully you can do some of the easy ones as a good learning opportunity. Usually, even if they're easy, they still require you to figure something out that's not obvious. So it's a good opportunity to try and apply some of your skills. But often you can be really stuck on the medium and hard ones, and it actually can be more discouraging than helpful, I feel, unless you're just really passionate about it.
So you kind of have to have that persistence to keep going at it.
Yeah, and some people get that immediately. Some people kind of learn it over time. But yeah, you definitely need to be persistent. You need to be able to handle some disappointment, because even some of the best teams miss the solutions on occasion. But then afterwards, people usually like to write up how they solved the problem, because not many people actually were successful. And so those write-ups get published. There's actually a few GitHub repositories where they kind of collect all the write-ups. And those are actually really good to learn some kind of more difficult techniques, how they were done in the past. And now that CTFs have kind of been a really popular thing for almost a decade, a lot of problems are kind of based on previous ones. So if you're doing a CTF, you can actually learn a lot by looking at what past ones did, and then the new ones probably are just a twist on what was done before.
Mm-hmm. That's very curious. Okay, so I have the last question for you. What sort of advice would you give to someone trying to break into this field and find their niche and actually, thrive?
Yeah, I mean, it's a great field to be getting into. There's tons of opportunities right now. It's a bit of a kind of crusty, hard outer shell to break through. But then once you're in, I think you've got a lot of opportunities. Um, I would advise that people really just try a lot of things, whether professionally, like get a job doing it, or whether just do it for fun or talk to people that have done it, because it's actually a very varied field. Something like blue team operations management versus red team exploit development are going to be entirely different skill sets. And there's a lot of different areas you might be passionate about and not realize till you learn about them. I think for a lot of security jobs, it really helps to have some passion because otherwise it can get too disheartening when you're not getting things working, or it can just feel too mundane if you're just doing the same thing every day, or it can feel too discouraging if you just see the attackers always beating you and you're never winning. So I think it helps to explore a lot of areas, see what you're passionate about. And then otherwise, I always just recommend that people learn as much as they can and practice as much as they can. For me, I have a hard time learning something if I'm not interested in it. So that's why I say figure out what you're passionate about. And then I think it's a lot more natural to want to learn more about it. It actually doesn't take a long time to become almost an expert in an area if you just focus on it and learn and try it out. So I'd really recommend that people just find something they're interested in and just start trying it out.
Yeah, very cool. Well, thank you very much for your thoughts. I think they're very valuable and will be useful for students to get started.
Awesome. Thanks for having me.
For sure.